Hello and welcome back to Data Analysis and Visualization. I'm Jivita Christie, and in this video, I'm going to explain to you K-means clustering, which is a very popular clustering algorithm. If you need to refer to the basics of clustering, please watch one of my previous videos on Introduction to the Basics of Clustering, which is linked down below. So let's begin. K-means clustering is perhaps the most popular clustering algorithm in existence, and it is extensively used in all real-world applications for clustering. It is relatively simple, intuitive, and great for beginners to conceptualize some machine learning concepts. And it is an unsupervised machine learning algorithm, and we're going to now see how K-means clustering actually works. So first of all, we already know what K-means clustering is. We want to cluster our data into different clusters, so sort of group the data into different clusters. And this would help us to make some future predictions. Now, how do you start about doing this clustering? So first of all, you have to identify K. So K can be intuitively identified, or there are two methods called silhouette method or the elbow method, and we would discuss that in one of the next videos if possible. So intuitively identifying K would be that you just go through your data, which is right here, and you can see that just from the data that this could be grouped into two parts. So there can be two parts. So if that's the case, then you'll just intuitively decide that your data can be clustered into two parts, and that's why you're choosing K as 2. So you can choose K intuitively by, first of all, understanding the data domain. For example, if you are trying to cluster amongst newspaper articles, you might have quite a few types, whereas if you're clustering on customer types, it might be better to start with a smaller K because newspaper articles are so many. But if you're talking about customers are going to be types of customers won't be as many newspaper articles as you have. So depending on that, you would select K, or you could explore it visually to see if you can spot some natural clusters. So visually would be something like this. You plot all your points, make a scatter plot, and then just look at the scatter plot and decide if you can naturally pick out some clusters, some groups that are forming, and decide K on the basis of that. The step 2 is once you have the K, which right now we've just taken as 2 for an example, then we select K random points from our dataset and use these as centroids. So because we have two clusters, K as 2, we will select 2 points as our centroids. And these points are random. They don't have to be actual centroids. So these are just provisional ones. So here we have C1, which is blue, C2, which is yellow, and both are centroids of two different clusters, which we are picking at random. Then comes the step 3, which is to assign all points to the closest cluster centroid. So that means because this is my centroid C1, that means that everything near C1 is going to turn into blue, and everything near C2 is going to turn into yellow. So all points closest to C1 get assigned blue cluster. All points closest to C2 get assigned yellow cluster. Now all you need to do is just look at it. Look at your data. And for example, if you're looking at this point, is this point closer to C1 or closer to C2? We know it's closer to C1, so this point will be assigned a blue cluster. That's how clustering works in step 3. Then we have step 4. We compute the new centroid of these clusters because we do have a cluster now. And these centroids were merely provisional centroids. So now we are going to calculate new centroids. And now the blue and yellow crosses that we have right here, they represent the centers of the newly formed clusters, as you can see, because now these are the clusters. And now we can, because we have clusters, we can calculate and find their centroids instead of randomly picking two, which like we did earlier. Then we have step 5, which is where you will repeat steps 3 and 4. So now you have to repeat steps 3 and 4 and use the new centroids as the cluster centers, and once again assign the closest points to each centroids cluster. So once again, you're going to do clustering, and this time you're going to use your new centroids and perform the same type of clustering. So once again, everything does not remain blue and yellow. They become white again, and then you start once again with the new centroids. And you keep repeating this step until the newly formed clusters, they stop changing, which is also known as the point of convergence. When your newly formed clusters, they stop changing, which means it's possible that because last time you selected this as C1, this as C2, it's possible that some of the clusters, some of the points which became blue are now actually becoming yellow with the new centroid. So if that's happening, that means there is still clustering process happening. But there will come a point when the centroids will be so perfect that the next time you do clustering, there will be no change, no point turning blue to yellow or yellow to blue. So that is where you will stop, and that is known as the point of convergence in clustering. And now it's not always possible to reach convergence. So sometimes whatever results we have approximately after a certain number of iterations might be the results that we want to stop at. So there are two things. The clustering algorithm can stop when it reaches convergence, which means there are no blue points becoming yellow or yellow points becoming blue anymore. Or it could be stopped when some number of specified iterations is reached. So you could probably want to run your algorithm for 500 iterations, which means after 500 iterations, your clustering algorithm would stop. Now let's take a look at some of the advantages of K-means clustering. It is relatively simple to implement nowadays. Due to all the libraries, it's even more simpler to implement. And scales to large data sets. If you have a large data set, you can scale the clustering algorithm to fit that. It guarantees convergence. So it is not, there are some algorithms that do not guarantee convergence, but K-means clustering is not one of them. So at some point you will have convergence, which is a good thing. So your program won't be just running forever, and can warm start the positions of centroids. So you don't always have to have exact positions of centroids. The clustering algorithm takes care of that. And it easily adapts to new examples. So if you introduce new data into your data set, it's going to adapt to it. And it generalizes clusters of different shapes and sizes like elliptical clusters. So they don't always have to be circular, they could be elliptical clusters as well. And some disadvantages. You still need to choose K manually. You have to pick the value of K, and it is dependent on initial values. You can run into problems when you're trying to cluster, when you're clustering varying sizes and density. And it is sensitive to outliers. So if you have data which is you have some data points which are far away from everything else, they are outliers on your XY plot or scatter plot, then clustering is obviously sensitive to such outliers. And it doesn't scale well with a large number of dimensions. So if you introduce height, weight, all such dimensions, then it's going to not perform very well. And this can be mitigated by using PCA, which is principal component analysis. Maybe I will do a video for that in future. It only works for numeric values. For example, if you have categorical values, numeric values are just XY points that you can plot. But if you have categorical values, for example, if you have high, medium, low, and if you want to do that, or positive, negative, if you want to perform on that, it's going to be difficult. So they would have to be translated into some numerical meaning. like high, medium, low could be mapped to 3 to 1, but they don't always work for categories like types of fruits and all. So if you have numerical values, this algorithm is going to work very well. But if you have, however, categorical values, then it may not work that well. So that's where we would be using classification. Now we are going to see a small Python code to implement clustering using K-means algorithm. So let's see. So once again, I'm going to be using Google Colab notebooks to run this code, and you could do the same by going to your Google Drive and using Google Colab. So this is K-means clustering Python demo, and it's a very simple code. We are going to create our own data set. So to do that, we need, and to run the whole code, we need two libraries, matplotlib for plotting and sklearn.datasets right now to create this data set. So there is a function available over there called make blobs. If you use that, you can create your own data set. And this is how you do it. We need X and Y points. So because we are going to plot our data, two-dimensional data in an XY plane. So we need X and Y points. We're going to call this make blobs, and we're going to see how many samples we need. So I'm going to create it for 100 samples. So 100 samples, 100 values, 100 points, and number of features we want to. How many centers do we want? You can see there are 3 clusters, so 3 centers we want. Okay, and we want a cluster standard. These are some parameters that you can just fill in, and we want 2 classes with 3 centers, and shuffle true, which means we want these points to be shuffled. We don't want them in an order. And the random state is equal to 7. So this is basically related to convergence, how long your data will take to converge. And then we are going to use matplotlib pyplot library, and we are going to plot all these points here. To do that, we just do plt.scatter because we are creating a scatter plot. And we are going to plot all the values here, X and Y values, and with a yellow color circles, the edge color is black, and that's it. And we're going to just plot it. And you can see this is the plot that is generated with this. Now let's see how you can do K-means clustering on this. So for this, we are going to import sklearn.cluster, from where we are going to import the K-means algorithm. And we are setting k equal to 3 for the first trial, which we're going to run 10 times, and for 500 iterations. We are selecting k equal to 3 intuitively because we saw the data that was plotted and we saw that there are 3 clusters. So it is intuitive, k equal to 3. And n clusters is equal to 3 because we selected k3. Initialization, we want random, initially picking the centroids, and init is equal number of initializations is 10. Maximum iterations, we are not waiting for convergence. We want the algorithm to run 500 times and then stop. So that is there. And there is a tolerance. This is the default init and tolerance value. You can increase or decrease tolerance. If you have some convergence issues, like if your algorithm is running too long and not converging, then you could choose larger values of tolerance. It is up to you. But for now, our algorithm is very simple. Our program is very simple, having very less data, so this won't affect us. Next, we are just going to do y_km, which is the variable in which we are storing whatever this function generates. So we are going to do km. Km is our variable in which all this got stored. Now we are going to do km.fit predict x. So x is what we generated here, and based on x, we are going to predict the y. So it is again just like regression when we did. And once this ykm is ready, you can just look at what it is. So if you do that, you'll just notice that it's just a bunch of points. Okay, it's just a bunch of clusters that are created. So when you want to visualize this, you're going to do it in this manner. You're going to, because we created 3 clusters initially, because we selected K as 3, that's why we know that there will be 3 clusters. So to plot those clusters, you need to use this type of a function, plt.scatter. And see, just notice how I am putting the coordinates. So there are 0, 0 and 0, 1 for the first cluster. And we can just decide to give whatever color we want to it, a light green, black edge. And then same way we have the second cluster with a different color. For that we are using coordinates 1, 0, 1, 1. And for the third cluster we have 2, 0 and 2, 1. And we are just labeling all those with cluster 1, 2 and 3. And you can see this is the plot which is created. So these are all, this is the first cluster, second cluster, third cluster. And if you want, you can plot your centroids as well by writing this code here, which is scatter. And feel free to pause and implement it on your own at this point. So now you have centers. To find the centers, this is the thing you can do. km.cluster_centers 0 and cluster centers 1. So if you do that, you get both the cluster centers, and you can just print them as red stars, as you can see. So that's it, and you can just show the plot here. This is what the clustering looks like. So I hope you understood K-means clustering using Python, and I'll be back with the next video. So I'll see you there, and thank you for watching.